Did Indian Ocean swell actually hit California? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, June 1st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please click the Stormsurf icon down in the lower right-hand corner of your screen. That'll get you all set up. If you have a comment or question, write it up down below. We'd be happy to respond. Love hearing from you all. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. The heart with the $sign on it. With that, I'd like to thank the folks that donated last week. Coach Nate, Tim Caston, Iowa, Our Predicament, Peter Carpenter, Eastlate, Evolution Moto, Dave Frankel, and then an anonymous direct contribution. Thank you. I know who you are. And then our big contributor for the week, Don Mendotrin. Very generous contribution, Don. Thank you so much. And with that, let's get to work. We'll start by looking at significant wave heights around the planet, starting North Pacific, little area of 20-foot seas, really targeting Alaska and maybe some of the Canadian coast, but certainly not the majority of the U.S. West Coast. Notice seas here building off of Cape Mendocino. We'll get into that in a minute. In the southern hemi, 29-foot seas southeast of New Zealand. This is associated with a new swell in this area, pushing off to the northeast. Hooray for us in California. North Atlantic, not a whole lot going on. Things are pretty quiet now. South Atlantic, broad area of low pressure has produced seas, but you see most of it pushing west of South Africa, and really now focusing on the Indian Ocean. Another fetch off of Australia, Western Australia, with 24-foot seas targeting the Australian west coast. Highest seas over the planet, 29.8 feet at 49 south, 171 west, right here. So the southern hemi in the Pacific Ocean takes the honor this week for the highest seas, at least for the moment, anywhere on the planet. But before we get into all that, let's take a look at current conditions. We're going to look at the buoys starting up north off the North Oregon coast, off of Columbia River intersection there, the border between Oregon and Washington. Grays Harbor buoy, number 036. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period energy, a tenth of a foot. That's on this end of the chart, and we're looking at the scale out here. These are the period or different frequencies. This chart goes the whole way down to 5-second periods. That'd be just pure wind swell. We're looking for any bumps. You see right here, 8.5 feet in that one band at the 8.3 second band. So wind swell for sure there. Little bump of something going on here at 20 seconds. I think we know what that is. We'll get into that. And a variety of, basically southern hemi swell, but nothing particularly standing out. Then we go down to Northern California. Point Reyes buoy 029. I mean, maybe this is a little bit too far north for this time of year. Maybe we should go look somewhere off of Monterey Bay, but we'll do this at least one more time. Point Reyes buoy there, just north of San Francisco. Same deal. Whole bunch of wind swell showing up. I mean, 3 to 4 feet continuously the whole way up to 12 seconds. Then you see building swell at 20 seconds, another little bump of something out here at 25 seconds. So a variety of swells in the water. Then we go down to Southern California, the Point Loma South buoy 191 off of San Diego. Much better defined or more clearly defined pattern here. Southern hemi swell, main period or peak period at 16.7 seconds, 1.7 feet of energy, but it's really everything on either side that really makes the makes up the entire energy in the swell. You can see here. Primary swell 2.7 feet at 16.7 seconds from 190 degrees. Theoretically, that's surf at 4.5 feet roughly. And then some wind swell in the mix, 2 feet at 10.2 seconds from 258 degrees. Theoretically making surf at 2 feet. So that is the prime focus. I didn't do this analysis up in the northern buoys, but you know, this is really what everyone's looking at other than the wind swell. Then we go to the south shore of the Hawaiian Islands, the Lanai buoy, 239. This is protected from any wind swell. You see a bump of energy at 15.4 seconds, 1.5 feet, and then some other mixed energy in there. Primary swell, 2 feet at 14.9 seconds from 176 degrees. That is the same southern hemi swell that is just now starting to arrive in California. Surf height's 3.2 feet. I haven't looked, so I don't know exactly what's going on there, but that number generally is pretty right. And then you have the wind swell mixed in at 2.3 feet at 11 seconds. That could actually be residual other background southern hemi swell from 185 degrees. Another bit of 2.5 foot energy, so generally all in the waist high range. So what's been going on for the past week? Okay, we're looking at hindcast wave models, significant wave heights. We're back to Sunday, the 25th of May, starting 18C. A little bit of a gale here, producing 17.1 foot seas, the highest seas over this entire domain. Not a whole lot. No, you know, and no. Yes, so maybe some background swell resulted for Hawaii, but of more interest was this gale that developed on Tuesday, Wednesday, 20-foot seas falling southeast over the dateline. You can see the front right there, the swell front. That actually did, and Alvin over here, pretty much gone now. I think it reached tropical storm status, and that was it. See, the swell front hit the north shore of the Hawaiian Islands on Saturday. There was definitely some surf there. You know, very late season, seeing how we're practically in June. And then let's get this out now. Here is our current gale. This is 12Z Sunday, 23 feet, but you see the arrows, the swell vectors all aimed north, targeting Alaska. Maybe sideband swell somewhere down here. Will result for Canada, but I would think nothing more. And there we are, current time. Then we go to the southern hemi. On Saturday, the 24th of May, a gale started developing southeast of New Zealand. Nothing huge. There's 29 to 30 foot seas. This was on Saturday, the 24th. Building to 31.7 feet Sunday a week ago. There's the ice anomaly popping up. It actually dropped out for a day or two. And this system pushed off to the south, or off to the east. Let's see, I'm trying to figure out, 118 right there. That's the San Diego cutoff. So it was still in the California swell window, even into Monday with 29-foot seas lifting off to the northeast. But by about 18Z, maybe in the afternoon, that was it. There's the swell front. This is a swell that is just starting to hit the buoys in San Diego now and up into northern California and maybe really long period energy, you know, 1/10 of a foot up into Oregon, but probably nothing really rideable. And then we continue on through the week. We're into Wednesday, Thursday. Notice there was something there in the Tasman Sea. If you're en route to Fiji, well, the swell is probably already hit by now. There's Fiji. But of interest, another gale developed behind that on Thursday, the 29th of May, in the Tasman Sea. But really, it was, here we go, on Friday night, the 30th of May, 30-foot seas developed just barely off the coast of New Zealand and continued to build secondary fetch with 34-foot seas. Again, this is Saturday, the 31st of May, so just a day ago, and then lifting off to the northeast. And there's our current image. So one swell hitting California, another swell here developing off of New Zealand, or another gale at least, that will produce a swell that certainly will reach up into Hawaii and into the U.S. West Coast about a week for Hawaii, and maybe 9 days or so, 8 or 9 days from now for the U.S. mainland. Now we're off to the North Atlantic. We're just reviewing what has been happening over the past week and seeing how that meteorologically today is the start of summer. I think astronomically it's either the 20th or the 21st of June, but things definitely winding down. We'll just roll this out, and there we are, current time. So not a whole lot happening in the North Atlantic. For the South Atlantic, a week ago, there was a gale, 40-foot seas, pretty much pushing off to the east. Swell from it did push up into South Africa. I'm not sure how much size. I mean, you can poke around on the YouTube and see some videos. Another little bit of a disturbed weather pattern. I wouldn't even call it a gale, pushing south of South Africa on Wednesday into Thursday. And you see the main fetch falling south. More energy developed later on Thursday out in the middle of the South Atlantic. This looks much better in terms of South Africa. You can see energy from it seeping up into the coast as of yesterday and into today. There's 18Z. You see the front pushing up. My guess is it's probably pretty raw. Yeah, Jeffreys Bay, something like that might be doing pretty well. It's a little bit more protected. And then finally, the Indian Ocean. Things were moving pretty good a week ago. You can see the pattern that was in play. You see some sort of a swell here pushing towards Bali in that area. This was on Wednesday into Thursday. Now, here we are starting to approach where we are. A gale, 30-foot seas on Saturday, a day ago in the upper reaches of the Indian Ocean, targeting Bali, Indonesia, and Western Australia well. Another broad area of 29 to 30-foot seas we're pushing under South Africa. Let's see, there we are right now. That certainly looks like a pattern. Nothing huge, nothing crazy, but certainly steady, consistent surf looks to be en route to Western Australia and Indonesia. Now, in last week's video, we talked about a storm that developed in the Indian Ocean on the 19th of May, 06Z Monday. Here's the peak of it. Seas were 54.3 feet. We did the Great Circle analysis. You can go back and look at that video and go scroll, use the quick search to go find exactly where it is. But the short of it is, this system was on the Great Circle path to Southern California. I've never realistically seen any swell from the Indian Ocean make it into California, even though technically it's possible. So we did the math. We said, well, the 25-second period swell would hit Wednesday, the 28th of May at 7 p.m. Then by Friday morning, we would see 22-second energy, and then by Saturday morning, 20-second energy into Southern California. So let's go take a look and see what actually happened. So this is the 29th. This would be Thursday morning. Well, in Z time, yeah, what is that, like 1 a.m. in the morning? We said that the 25-second energy would hit at 7 p.m. on Wednesday. By Thursday morning, boom. Not 0.1, but 0.2 of a feet. Not very much. What are we talking? What's 0.2 of a feet? Maybe 4 inches at 25 seconds. But I was watching. There was this steady, a tenth of a foot background energy. But when it popped to 2, I go, oh. And in 25 seconds, that's hitting the profile. And then it went to 0.3 of a feet by about 7 a.m. Continued at 18:30, so what's that, about 11:30 a.m.? And then in the afternoon, dropped to 0.2 of a feet, but also started building at 22.2 seconds, which would be about what you'd expect. So roughly speaking, this is probably like 24 or 23 and a half second period energy. And then around 5 p.m., up to 0.4 feet at 25 seconds. Then Friday, about 7 a.m., 22.2 second periods, half of a foot. That's almost rideable surf. It was supposed to transition to 22 seconds when you do the math at 4 a.m. So this profile clearly looks like that Indian Ocean swell. Let's keep going. Later in the morning, 0.6 of a foot, so half of a foot at 22 seconds. That's, I don't know, a foot and a half maybe of rideable surf. And another reading, 0.6 of a feet at 22 seconds at about 2 p.m. That would be on Friday. And I think this is the peak, 0.8 of a foot at 22 seconds on, this would be the 31st. That was Saturday morning. So, and that's not, I mean, you got to consider what's on the shoulders. I roughly say, take this and multiply it by 1.5. So let's call it, I don't know, 1.2 feet at 22 seconds. So that's 1.5 feet at 22 seconds is, 2 foot, maybe a set at 3 feet somewhere in Southern California. Now, my guess is the consistency was one set every 30 minutes or more, and who knows how many waves would have been in a set like that. Probably not much, but you get the general idea. I think the Indian Ocean swell actually did hit. I have more readings. I'm not going to bore you with all the details, but you can kind of see it. This is the peak of it here. It seems like Indian Ocean swell did hit. This was all before any of the swell that was generated in this other gale that's starting to hit now. This was all well prior to that, and it actually started dropping off before things started picking up today. So my guess is Indian Ocean swell actually did hit California. Hard to believe. That distance was, the travel distance, if I recall, was 9,700 nautical miles, and that took a good amount of time, 10, 12 days, something like that. So, pretty amazing. All right, so what's to come? We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north, just like we have right here. No big surprise, New Zealand there. We know there's a gale here, so it's sort of almost cheating. But anyway, when you get a trough, a push in the jet like this up to the north, it creates a clockwise circulation, like an eddy here. That circulation also manifests itself down at the ocean surface if it's strong enough. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, imparting energy into the ocean, creating seas, and eventually those seas will radiate away from the fetch area. The lesser period elements will fade off, exposing pure swell. And of course, swell, when it hits your beach, turns into surf. But it all starts with a trough. So that's what we have right now in the southeast of New Zealand. But over in the southeast Pacific, we have a ridge, the jet pushing to the south. Kind of get this split pattern going here. That produces high pressure, actually would be circulating this direction in the southern hemisphere. Does nothing for swell production. So right there, that's our big thing. Looking forward, we're looking for any additional troughs. And then here we go. We're into Wednesday, the 4th of June. New trough starts building with being fed by 140 knot winds. Maybe a little bit stronger. There we go. Looking better. The Southern California cutoff. For San Diego, like 117, 118 west right there. So we're into Thursday, and then that fades out. Now here comes a big ridge building. There is a trough here over New Zealand, too, on Thursday, the 5th of June. But it's too pinched, too tight to do anything. This ridge with 190 knot winds pushing to the southeast. Pretty much, and there we go to 200 knots, certainly suppressing support for gale development. But then you get this sort of another ridge pushing under New Zealand, marrying up with that ridge. You almost get something that looks like a trough right here. And winds 200 knots, maybe even a little bit more. That certainly looks conducive to gale development, and we'll roll this out, and here we go. So maybe something to look at a week out from now, but the models, I never trust them more than about 3 or 4 days out. So let's go down to the surface. Surface level pressure, surface level winds, remnants of our gale east of New Zealand, still producing 35-knot northeast winds aimed well at the U.S. West Coast. You really need 40-knot winds, though. I mean, this will get you a 13-second period swell. Pretty much the 16-second period is kind of the magic number where you don't get nearly as much decay in the swell, and it shows up and it actually seems like a real swell. So I'm going to sort of just write off anything here for right now. We know there's a trough over here, and sure enough, here you go. You see some sort of low pressure trying to get organized, but it winds 30, 35 knots. Another gale developing southeast of New Zealand, 40-knot winds, all aimed at Antarctica. That does nothing for our forecast area. We're into Thursday, Friday. Now we know that here's the ridge. You can actually see it even at the surface. And then a little gale trying to organize with 45-knot winds. Nope, it fades on Saturday. There we go. Tries to spin up again, 45 to almost 50-knot winds, right on the hairy edge of the Southern California swell window. This would be Saturday night into Sunday, and we'll just roll this out. 35-knot winds over a broad area. Yeah, but what would we get? I'm going to guess 22 or 23-foot seas. Just eyeballing it. That's probably not enough to make meaningful swell, at least up into Southern California. Certainly, though, for South America and Central America, something should result from that. All right, so let's go to the significant wave height model. It takes the wind data from the GFS wind model, which we were just looking at, and projects that onto the ocean's surface, and then does the math to say, if you have, let's say, 35-knot winds blowing over a 600 square mile fetch area, aimed to the northeast for, 12 hours, it will generate 29-foot seas, 29.8-foot seas, or something like that. Now some of this energy is from previous fetch, too. But still, as of right now, 29-foot seas pushing off to the northeast. Put this in motion. Fetch pretty much dying out as we get into Monday, and that's the end of that. We continue out. Now notice the ice anomalies here. The model does not project ice breakup or anything. It's only the hindcast that does that. So there's our ridge starting to build on Saturday. We're looking for something over here, 29-foot seas. 30-foot seas, where's 118? This is really pretty much east of this, even in San Diego's swell window. Good for South America, though. Nothing huge. Then look at this. Right at the 180-hour mark, fetch increases in size right on the hairy edge of the Southern California swell window. So we'll see. Again, it's a week out. Don't believe the models, but at least it gives us a little hope. Let's go check out the North Pacific real quick. I'm not even really looking here. I'm looking here. That is 22-foot seas made by a local pressure gradient. We'll get into the details of this in a minute. And that continues. Let's see, we're into Monday. That's big seas for local winds and local wind swell. Theoretically, you could get wind swell with a 13-second period somewhere down the California coast. Of course, there's southern hemi swell hitting at the same time, so the real question is, where are you going to go get the southern hemi swell away from the northwest wind swell, or vice versa? Who knows? I guess we'll see how that all plays out. Anyway, you get the sense there's some sort of continued fetch here. We're into Tuesday and Wednesday, and Thursday and Friday. Nothing else in the greater North Pacific, so I'm just... Finally, it looks like by late in the work week into Saturday and Sunday, that gradient finally settles down. Another tropical system forecast sneaking into the picture right about the same time. For the North Atlantic, we'll put this into motion. My expectation, there you go, believe it or not, 22-foot seas, targeting Ireland pretty well. and the North UK, Scotland area, 23.5 foot seas forecast on Monday night into Tuesday. That'd be just pretty much local wind swell, though. It's right literally pushing into land. After that, pretty quiet pattern, not unexpected given the time of year. South Atlantic, broad area of 26 to 28 or 29 foot seas. Let's see, 29.1 feet, somewhere probably right there. Okay, all that mess certainly agitating the ocean seas, building to 34 feet as we get into Monday. I don't think any of this really is, I mean, it'd have to almost be going backwards to get up into the southeast coast of Africa. So this is more going to target the Indian Ocean. Another little gale develops here in the main central part of the South Indian Ocean. That looks entirely possible, pushing swell into southwest Africa. This is on, so we're into Friday already. Then things, let's see, we'll just see. I don't want to say it quiets down, but yes, it looks like it does. Okay, onward to the Indian Ocean. And I kind of noticed this last week. It seems like the South Atlantic, yes, reasonably active, but the main focus of energy seems to be here, and then over off the chart, somewhere around New Zealand. Let's see what comes from all this. Here we go, 34 foot seas, pushing off to the east, not very large in coverage, that all fades out. But then another gale develops with 37 foot seas. This would be on Thursday, the 5th of June. That all kind of falls apart, but then tries to keep hanging on. I'm looking for something really strong that just is barreling across the southern oceans. I'm not seeing it. That doesn't mean there isn't going to be surf. Just means it'll be more, I'll call it moderate surf. Local wind forecast mainly looking for the potential for production of wind swell relative to California and Hawaii. High pressure, 1038 millibars, in control in the eastern Gulf of Alaska, pushing hard into Cape Mendocino. Heat low inland creates local low pressure. The difference between the high pressure and the low pressure tightens up the isobars, creating what's known as a pressure gradient, and that generates wind. 35 to 40 knots as of right now off the Cape Mendocino coast, building to 45 knots this evening, and then back down to 40 knots. That's strong wind, but also notice that the low pressure also sort of moves over the ocean. That sets up an eddy flows. So low pressure circulates counterclockwise, high pressure clockwise. The big difference in pressure between there and there, well, you end up with this eddy flow, the south winds pushing along the coast. That's kind of a good thing. In fact, I was just typing a response to somebody in the forum from last week's video, and we were talking about warm water transport up into California. And my general thesis was, well, if you get south winds and consistent south winds, that really is the main mover of warm water from Mexico up into California. This is a classic scenario. North of some line like right there, with that north wind, it'll just be upwelled to death, and it'll just be water temperatures probably down at 49 degrees or something. But then somewhere down in here, you get this backflow warm water coming up. Theoretically, we'll see what really happens. Anyway, we're into Monday and Tuesday. You get the same picture, trades for the Hawaiian Islands at 15 knots. Wednesday, same sort of deal, trades 15 knots for the Hawaiian Islands. High pressure just hanging off here. Thursday, still the gradient continues with 30-knot north winds, but south winds from pretty much, I'll say, Point Arena on southward. Trades 15 knots for the Hawaiian Islands. Friday, the gradient finally starting to relax, so the eddy flow is still in control. Trades 10 to 15 knots for the Hawaiian Islands. Saturday, Same deal for California. Trades down to 10 knots for the Hawaiian Islands. See if we can get into Sunday here. Finally, it looks like the gradient settles down completely, and you start with a light northwest flow for north and central California. Trades 10 knots for the Hawaiian Islands, and there we are, 180 hours out. And it'll take us a week to get back to normal. Now, let's be clear. This strong pressure gradient off Cape Mendocino, it happens every year, once, maybe twice. I hope it's only once. But you know what? When there is no southern hemiswell, the wind swell is a godsend. At least it's something to ride. So, I don't want to get too down on the wind swell thing, though. When you have decent southern hemiswell, it kind of really messes things up, at least north of Point Conception. All right, we're not tracking snow anymore. There's no meaningful precipitation other than afternoon convective precipitation in the Sierra. But temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road. This is in Yosemite, the high country. It's about 8,700 feet there. This is the latest run of the model. For whatever reason, this model has been having a hard time updating because I gotta download so much data to get it to paint. We're painting temperature levels from anywhere from 500 feet up to 14,000 feet. So that's a bulk of data. Anyway, you see the general picture here, starting as we get into Monday. Temperatures 45 to 50 degrees sort of thing at that intersection, maybe building up to 60 degrees or somewhere in that as we get into next weekend. But by and large, pretty decent temperatures for hiking. All right, so what's all this mean in terms of surf? We're going to start up in Columbia River area again, the border between Oregon and Washington. Surf heights 4 to 5 feet Monday or so, then fading off. No real fetch aim there. North Pacific asleep, and southern hemiswell, whatever gets in, I think most of it's pretty shadowed, but you see maybe some 3.5 foot wind swell on Thursday, and then as we get into next weekend, 3.5 to 4 foot wind swell. Winds, stronger local winds northwest Monday, Tuesday, but then things settle down as we get into next weekend. Swell heights 5 feet at 8 seconds. 5.5 feet at 9 seconds. A little southern hemiswell in the mix. 2 feet at 13 seconds, something like that. But for the most part, wind swell in the 4 to 4.5 foot range at 8 to 9 seconds. Ocean Beach, San Francisco, the wind swell, just looking at the charts, out of control. It says 9 feet here on Monday or early Monday morning. The reality is Point Reyes is going to filter a lot of the size out from this. I mean, it's going to be a very steep angle, probably 310 plus degrees, so it's going to get shadowed. But anyway, in off Ocean Beach and exposed waters, surf height 6.5 feet, 7 feet sort of thing, and then finally settling down. Local winds, there's your south, some variation of the south eddy flow the whole way through. So that is at least something a little bit reassuring. Surf heights 9 feet at 10 seconds, 5.9 feet at 11 seconds. You can read the numbers. It's just steady, slowly declining wind swell with period 9.5 to 11 seconds. Southern California now, totally shadowed from the wind swell, totally open to capturing whatever southern hemiswell there is, and we know that one swell is hitting, just starting to build as we speak. Surf heights 5 feet. Monday, slowly, and this is not, amplified, it's just your standard beach break kind of thing. Exposed reefs and points could do up to 1.5 times, maybe 1 3/4 times better. 5 feet, 4 feet, you see the swell slowly settling down as we get in next weekend. Winds all but inconsequential, other than, well, let's see, the south wind has been a bit of a problem in Southern California. Doesn't look so bad, at least according to this chart, but you really need to get into the high-res local charts. All right, swell heights, 3 feet, 16.7 seconds. Monday morning, that is minimal significant class southern hemi swell for Southern California. Holding into Tuesday, then slowly dribbling its way down to 1.5 feet at 12 seconds. And then the next little bit of southern hemi swell starts showing up on Saturday. That's probably the beginnings, I'm guessing, but no, I don't think this is the beginnings. This is background swell. I think there's another, the New Zealand swell. This isn't showing on the chart yet, so that's probably just right off the corner of the chart. Anyway, background swell for next weekend, 1.3 feet at 14 to 15 seconds. South shore of Oahu getting some of the energy, 2 foot. I mean, this looks like a mix of wind swell and minimal southern hemi swell. And I'm guessing all this is wind swell, 4 feet as we get into next weekend. Let's go take a look. Yeah, I don't see any meaningful periods in here at all. 1.3 feet at 14 seconds on Thursday. And then here comes, oh, actually, so look at that. 4 foot, 2.5 feet at 16 seconds. So that is southern hemi swell. This is probably the New Zealand swell. Hitting Oahu first always hits about 2 days ahead of what it takes to get into California. So 2.5 feet at 16 seconds or so. That is pretty decent swell so far for this summer for the south shores of the Hawaiian Islands. Going over to Jeffreys Bay, surf height 20 feet. No, it's not going to be 20 feet there. Because it has to wrap in, Jeffreys Bay is a bit more protected. This is more like open ocean, let's say 2 miles, 3 miles off the coast sort of thing, but you get the idea. 20-foot big surf on Monday, Tuesday, then fading down to almost nothing, coming up again for next weekend. Winds out of the west. That would be offshore at 25 to 30 knots. That's pretty strong indeed. And then settling down. Let's go look at swell heights. 14 to 15 to 18 feet at 14 seconds, let's say. Then dropping off. And coming back up in the, a little bit, 3 feet at 16 seconds, now 11 feet at about 11 to 12 seconds sort of thing. So certainly an agitated sea state there. That's good news. And our final stop, Bali. Continue the swell magnet, everything pushing under South Africa up into the Indian Ocean. So 10-foot surf Monday, again 10 to 11 foot on Wednesday. That's probably a bit overstated, but you get the general idea. And then another burst as we get into Sunday in the 8-foot range. Let's see, swell height 6.5 feet at 16 seconds, 7 feet at 14 to 15 seconds. I would love some of that. 5 feet at 16 seconds plus. Yes, but it is winter in the southern hemi, so one would expect nothing less. So let's go look long term. What is the projections we use? There's 2 major weather oscillations that affect our weather long term, or at least in terms of surf production. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. First off, we'll discuss the MJO, the Madden-Julian Oscillation. There are 2 phases to the MJO, the active phase and the inactive phase. One is on one side of the planet, the other is on the other. They rotate around the planet west to east on the equator. Active phase on one side, inactive phase on the other side of the planet. They rotate west-east around like that. When the active phase is in the Pacific, the inactive phase is roughly in the Atlantic or something like that. All right? The active phase is like a low-pressure system. Because it's a low-pressure system, it takes warm, moist air down at the ocean's surface, lifts it aloft. That warm, moist air eventually encounters the jet stream. It feeds energy into the jet stream, making the jet stream stronger. A stronger jet stream is more efficient at producing troughs, and troughs, therefore, are good at making storms and surf. So the active phase is our friend. The inactive phase is the opposite. It is a high-pressure system. It has falling air coming out of it effectively, cloud-free skies, steals energy from the jet stream. The jet stream splits where the active phase is and downstream of it, and it's weak, less efficient at producing troughs and therefore surf. All right, so the other thing is the active phase dampens trade winds. Trades are made by high pressure. So when trades are weaker than normal in your area of the planet on the equator, then one can assume the active phase is in control. If trades are stronger than normal, then one can assume the inactive phase is in control because it's high pressure and trades are made by high pressure. All right, so let's take a look here. What is this? This is data from the TAO buoy array, a series of buoys strung across the Pacific on the equator, used for monitoring El Nino, but there's also wind sensors on those buoys. So this is the West Pacific here. This is the East Pacific here. 0 is the equator. Date line right there. That is New Guinea right there. We're looking at the arrows. The stronger the arrows, the stronger the wind. So trades out of the east, strong in the East Pacific, pretty strong in the Central Pacific, pretty strong in the West Pacific. But it is not the actual wind speeds. The way you tease out the MJO is by looking at the difference from normal for this time of year, right? The delta, the anomalies. Looking at the trade winds in the east there, just looking for the arrows. There's one little arrow pointing sort of east, and the rest of them are almost non-existent, so pretty much almost normal. Neutral in the Central Pacific, and maybe trades a little bit stronger in the West Pacific. So inactive phase maybe, and just a neutral MJO pattern. Kind of hard to tell. Let's dig a little deeper. Let's go look at a forecast. Here's the zonal wind anomaly forecast for the entire planet, all right? You can't see the tag here. I'm just trying to get it centered on, but right there, that's the date line going right up there. Far West Pacific starts at 135 east, so right there, all right? So you can see the blues are easterly anomalies, the oranges and yellows westerly anomalies, so one could say that's the active phase of the MJO, but it could also be the La Nina. La Nina is effectively like a long-running inactive phase of the MJO, and the El Nino like a long-running active phase of the MJO. Now, sitting right over the maritime continent, the blues easterly and stronger than normal easterly trades over the date line. Here is today. Starting today, westerly anomalies are to creep into and over the date line. This is very good news. That should happen in the next 5 to 6 days. Now, this model showed it continuous after that, and now it's showing easterly anomalies trying to return. But you notice the westerly anomalies make it, we'll pull this up here. Only they sort of make a foray back, and then westerly anomalies pretty much take over the Kelvin wave generation area, the West Pacific. And why is that so important? Well, that's where if the jet stream is running west to east over the West Pacific and it hits westerly anomalies and that upward flowing air and that energy gets sucked into the jet stream, then that's good for strengthening the jet stream downstream of where this convective area is. So I call this the Kelvin wave generation area, and but it is also really the main area for feeding energy into the jet stream. So this is looking muchly improved, but this is probably the worst of the models. Let's go do a little bit more digging. Outgoing long wave radiation. Fancy words for cloud cover. The blues, more cloud cover than normal. The oranges, drier than normal air. So this would be active phase. This would be inactive phase. South America, Central America, Hawaii, Australia, New Guinea, EQ right there, the equator, the date line right there. Very, very weak MJO signal, and that's not unusual. Typically in the summer, the MJO is weak. It is in the winter months, and especially in the Gulf of Alaska dateline region. That's where the MJO really shines. But for right now, very weak active phase over the maritime continent, just consistent with what we saw in the other model. Now it's supposed to ease into the Pacific 5 days from now, 10 days from now, and on the dateline 2 weeks from now. But the model has been teasing this for weeks now, and it never really materializes. Now, this is a statistic model. The dynamic model showing perhaps a little bit stronger active phase pattern. I mean, at least what is forecast to happen is active phase, not inactive phase, suggesting the atmosphere is trying to purge itself of the last remnants of La Nina. Let's go look at phase diagrams. The same two models, statistic, dynamic model here. Statistic model, wherever the heavy dot is, so right there, that's where the active phase is. And how do you read this? Well, the active phase moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic to Africa, back to the Indian Ocean. This does not show the inactive phase, just the active phase. So right now, oh, and if the dot is inside this circle, it is considered extremely weak. So a very weak active phase over the maritime continent. Per the statistic model, moving into, well, there's the West Pacific. I'd say this would be the East Pacific and weak 15 days from now. The dynamic model basically showing the same thing with the active phase a little bit further outside the circle of death here. So weak to modest active phase 2 weeks from now in the West Pacific. At least that's a step in the right direction if it happens. Another statistic model showing upper level or support for precipitation at the upper levels. Basically, I guess you'd call this cloud cover. Greens would be the active phase, more clouds than normal. Reds and yellows, inactive phase, drier than normal air. South America, Central America, and New Guinea, 0 is the equator. Dateline roughly there. This model has been saying the same thing for 2 months now. Active phase over the maritime continent. I think that is absolutely true. The active phase is stuck over the maritime continent. But will it move as projected here to the dateline by June 16th? And then even a little bit west to there on the 21st? Who knows? I don't know that I believe this. And then the inactive phase coming in behind that for the latter part of June into July. That's what the models are saying, but I think the MJO for right now is stuck. Then we go to the CFS model. This is like a long-range dynamic model. The GFS model only goes out 2 weeks. This goes out 3 months, if you believe that. All right, dateline 180 right there. Again, this is the east-west component of the winds, the blues easterly anomalies. In this case, either the inactive phase of the MJO or La Nina. You notice as you look down here, this is past performance here. And when you get to about here, there is a marked change in the intensity of the blues and the position of the blues, and they start shifting off to the east. And you see here the reds, which are westerly anomalies, active phase of the MJO. This actually has, that's the MJO. This is the black contour, but you see there's really no contours. That's because the MJO is so weak it doesn't even really show on the way this chart is scaled. But you see the westerly anomalies. Well, this is yesterday's model. But they start working their, well, the far west Pacific starts right there. So theoretically today, westerly anomalies are building into the West Pacific. They make it again almost 2/3 of the way to the dateline, back off, and then neutral anomalies take over for the second in 2 weeks of the month of June, signaling for sure the complete demise of La Nina and the development of a truly, I'll call it a neutral trade wind pattern across the Pacific, something we haven't seen in years. Then finally, the CFS model going out its full 3-month run. Past performance is down here, the forecast up here, dateline right up the middle of the chart. Far West Pacific starts here at 135 east. You can see literally a day from now, the 2nd, maybe the night of the 2nd of June, westerly anomalies start building, and we've been waiting for this. The models originally said this was going to happen on March 24th. That was, back in like December. Now here we are, June, 3 months later, and it's finally looks like it's going to come to fruition. But the big news here is westerly anomalies building over from the dateline, pretty much from the dateline and points west. If this materializes, and notice it's getting pretty strong here as we get later in July, a significant improvement, because that would mean much more energy being fed into the jet stream, and an improved jet stream pattern moving away from like the Atlantic and the West Indian Ocean and focusing maybe now more on the East Indian Ocean and the West Pacific. Let's overlay the MJO just to see what's going on. Right today, red contour, very weak active phase of the MJO, supposedly over the date line. Going neutral, weak inactive phase in the middle of June, and then a stronger active phase supporting stronger westerly anomalies as we get into July. But let's look at what's really going on here. The low pass filter. And this really says it all. The dotted contour is the high pressure bias. This is what supports La Nina. Over the date line, it's been here all winter and all spring. The third contour faded back in April. One more week, and the second contour fades. And once you're into a one contour high pressure La Nina, that means it is in a state of collapse. Now you have the, again, one contour low pressure bias here in the maritime continent, but already you get the sense it's trying to slowly ease its way into the Pacific. And by the time we get 1, 2, 3 weeks from now, it's going to start making a move, pushing, well, let's see, where is that? That's almost 2/3 of the way to the date line. If that happens, that would be very good. Not in that I think there's going to be this massive surge of storms or anything, but really it's about the balance of power in the Pacific finally shifting away from this La Nina pattern that we've been in for years now, maybe starting to shift at least to neutral. Now to the ENSO part of the discussion. El Nino or La Nina or what? Well, we're going to first start by examining subsurface water temperatures. This is the West Pacific here, East Pacific here. Again, the TAO buoy array, these buoys used for monitoring El Nino. These are the anchor lines on the buoys. The X's are individual sensors. They collect water temperature data, use the model to fill in the gaps. And we can see now this is not not Fahrenheit degrees, this is centigrade degrees. The 29 degree, that's warm water temperature, is actually moving from the date line to about 179 west. So it suggests warm water is moving off to the west. The 28 degree isotherm from 160 now to 159 or maybe even 158 west. All this is suggesting that, if anything, trades are fading. Trades would be blowing from east to west, like that direction. But this is saying if the trades are fading, then the warm waters in the West Pacific that's been held at bay by strong trades for years is going to start working its way off to the east. But it is not the actual water temperatures that matter. It is the anomalies. Again, the difference from normal for this time of year, we see neutral to warming water temperatures over the entire West Pacific and East Pacific. Whatever coolish water there is, this one little pocket here, it's pretty much doing nothing and just innocuous. So this suggests La Nina is already gone at depth in the ocean. Let's go look at some more charts. This is a high-res version of that same chart we just saw, but with satellite data overlaid on top of it. We can clearly see a massive pulse of warm water pushing its way off to the east for the entirety of the winter, and even up to about a month ago. It was here at 160 and points west, 160 west, and it couldn't move an inch. Now we see it reaching almost to 120 west. That's a point south of California. This is just on the equator, but this is effectively a Kelvin wave, a push of warm water pushing subsurface towards Ecuador. And if it arrives, and it looks like it's going to, I mean, there's a lot of warm water moving here. That's clearly suggests a change in the balance of the ocean and a push towards at least a neutral pattern. Let's go look at the satellite data real quick. It's pretty much the same as last week. Again, this is the equator right here. New Guinea, Ecuador right there. The Galapagos is there. New Guinea over here. Date line right there. These are not temperatures. They are the height of the oceans, the sphere of the ocean. Is it higher or lower than normal? Why does that matter? Well, if you have cold water at depth, get it in the camera there, cold water contracts, and when it contracts, it'll create a divot on the ocean surface. Warm water at depth, down, at the thermocline level, expands, and it'll displace the ocean's surface up above it. So this is a satellite that they strip out the wave heights, the wind waves, the tides, and is the sphere of the ocean higher or lower than normal? Well, it's higher here off of Ecuador, certainly higher here in New Guinea, over the date line to about 165 west. Now, it's only about 3 degrees north and south of the equator that really matter. And what this is saying is we're pretty much neutral. We have these pockets of cooling here, remnants of trade winds and springtime and a bunch of other stuff going on, but you can definitely see the sense that a Kelvin wave of some sort is trying to make headway to about here. Where is that? 130, let's say, 130 west. Something to keep in mind. Let's keep digging. Upper ocean heat anomalies. Oh, and here's the date, May 28th. So, and it updates every 5 days. This is going back a year. This is the West Pacific here, East Pacific here. You can see here's our La Nina signal, colder than normal water temperatures, all the way up until April, the beginning of April, and then boom, they disappear. Notice the buildup of warm water in the West Pacific, and then it's starting to flood over the date line and into the Central Pacific in the later part of April, and then building a bit as we get into May. Now, is this a real Kelvin wave, or is it more just sort of a regime change, change from colder waters to neutral to warmer waters? I think that's probably the case, because I don't think we've had like a massive westerly wind burst or anything, and nothing clearly indicating a shift towards El Nino. This is probably just warming to, well, look at the scale, 0 to half a degree above normal. So just a little bit warmer than normal. That's still way better than colder than normal. Warmer than normal temperatures. Now, this is subsurface. I better save this part of the discussion until we get into the surface data right now. See surface temperature anomalies, all right? South America, Central America, Hawaii, New Guinea there, 0 is the equator. Date line 180 right there. Now, you see, of course, everything is warmer than normal. That is the signal that NOAA and everyone have been concerned about, that the planet is getting warmer. It's pretty undeniable that that's the case. But regardless, looking here, and it's just 5 degrees north and south of the equator that really matter from an El Nino, La Nina perspective. We see white is neutral. A couple little pockets of cooling, a couple little pockets there, but warming there. I mean, overall, the trend right in here looks to be, or not the trend, but the current state is close to neutral. Now, yeah, we have cool waters here off of California and Mexico, but that is, again, springtime high pressure, creating those pressure gradients, and then upwelling out in here. This is normal for spring. This pretty much will fade as we get, that's somewhere into July, something like that. So this is looking good. Here is an alternate chart that just says, here, take the average temperature of all the oceans over the entire planet, go figure out what that number is, and then go block by block, like a quarter of a degree by a quarter of a degree over the entire planet, and what is the difference between that average? And then you see, well, maybe things aren't quite so warm as the previous chart says. I mean, they're bordering on neutral. Where's our scale? We're talking, what is this, 0.2 of a degree either way is neutral, so 0.3 of a degree below normal, maybe 0.4 out in here. Again, that's not really La Nina, but it would be nice to see just sort of neutral everywhere. The official El Nino monitoring region from 120 west, 5 degrees north and south of the equator out to 170 west, so right in here. This looks like, just eyeballing it, temperatures are a couple of tenths of a degree below normal. And then the Nino 1.2 region is right here. Looks like temperatures are maybe 0.2 of a degree above normal. Let's keep going. Sea surface temperature trend for the past 7 days. We always see neutral is green. Yellow is slightly warming. So we see warming out here. A little bit of cooling right here, and kind of neutral everywhere else. So the ocean's not swinging radically one way or the other for the moment. Again, it's only 5 degrees north and south of the equator that matter from an ENSO perspective. Here is the sea surface temperature value for the Nino 3.4, the official El Nino monitoring region for the week of May 21st. 0.2 of a degree below normal. Normal is considered anywhere from half a degree below to half a degree above. Now, this is corrected, pretty heavily corrected to try to take into account the warming planet signal. Here is data that is not corrected or not nearly as heavily corrected. And yeah, there was some sort of a hiccup here at Tropical Tidbits, but the data is reaccumulating, at least the current value. In the Nino 1.2 region there by Ecuador's 272 thousandths of a degree above normal. There's normal right there. Okay, and that's kind of what we saw in the sea surface temperature chart. In the Nino 3.4 region, in the official El Nino monitoring region, you can sort of see the trend value, the same amount, 268 thousandths of a degree below normal. Again, you have to be, if you're between half a degree above and half a degree below, you're considered neutral. We are neutral, but sort of on the low side of neutral. What does the atmosphere think is going on? So we look at the Southern Oscillation Index, the difference of pressure between Darwin, Australia, right there, and Tahiti, Darwin in roughly the Indian Ocean maritime continent, Tahiti in the Pacific, right in the smack in pretty much the middle of the Pacific. If pressure is lower in Tahiti, the index goes negative. Okay, we're minus 1.83, and we've been, kind of neutral the past 2 days. But we were pretty positive there. This suggests there was maybe like high pressure or something over Tahiti for a while. But prior to that, just looking back over the month, more bordering on the negative side than positive side. The 30-day average gives us sort of an idea. Which way are we going? We're at positive 3.62 today. Where were we a month ago? Well, we were negative there for a while. So this looks like we were in the active phase of the MJO, low pressure in the Pacific. Now maybe we're swinging towards inactive phase. Hard to say. The 90-day average, this is your El Nino, La Nina indicator. Again, if you're plus or minus 4 or 5, I think Australia says plus or minus 7, but plus 507, that's neutral. Where have we been? Pretty much unchanged for over the 90-day average. Let's go look at a graph real quick. Here's a 30-day running average for the Southern Oscillation Index. This shows you where we are today. Neutral, plus 7. Neutral, minus 7. So here was our El Nino back in 2023. It was really pretty much a failed El Nino. The downward spikes are the active phase of the MJO, stronger. Then we went into last year's weak Modoki La Nina. And now here we are in June, sitting pretty much dead neutral. Let's go see what the forecast says is going to happen over the next 3 to 6 months. The CFS version 2 model, sea surface temperature anomaly forecast for the Nino 3.4 region. Well, let's see, April, May, going into June, dead neutral. Maybe temperatures going 0.2 of a degree above neutral, then going back to neutral in October and staying there. This is actually an improvement because this model showed temperatures going down about 0.2 of a degree. I think it was even last week. The PDF corrected is effectively the same as this. I'm not even going to show it. So as neutral as you can get, again, 0.5 degree above to 0.5 degree below. This is, again, the model's just consistently saying a neutral year the whole way through the end of the year. That is a pretty rare occurrence. So let's zoom out. 1. Southern Hemiswell is hitting California as we speak, and some energy is also hitting into Hawaii. Take it. Make the most of it that you can. This system actually pushed pretty well off to the northeast. It wasn't huge. Seas were only 30 or 31 feet. But swell is in the water. You see it on the buoys. You can monitor. Go surfing. Of course, the problem is massive northwest wind swell north of Point Conception. Just going to have to play it by ear, make the most of it. The good news is another gale developing or has developed under and southeast of New Zealand. That swell will have a better northward push to it, targeting Hawaii and the U.S. West Coast, but it's a good long distance away, so probably won't be quite as big as the existing swell. After that, nothing really obvious on the charts. And then, of course, the longer-term outlook still looks like we're heading toward ENSO neutral. I wanted to put this in the title of the video. We're out of the spring unpredictability barrier, and literally within a day of that happening, the CFS model goes and pushes the forecast up a little bit, nudges the sea surface temperature up 0.2 of a degree, setting us again just as smack dab in the middle of neutral as you could possibly get. Now, the reality is, I would say we don't really know what's going to happen until we get into July, probably the latter part of July. But for right now, things are looking, especially with the CFS model, suggesting westerly anomalies building in the West Pacific. I think that'll set us up pretty well for this fall and coming winter, because then the jet stream will be pushing over that area of westerly anomalies, picking up energy. That should do good for California in terms of precip next winter. Yeah, can you believe it? It's barely June, and I'm talking about snow and rain for the Sierra, out 6+ months from now, 6 to 9 months from now. But we'll see. The fundamentals are looking good. It's taking longer than we thought to get there. But I think westerly anomalies are going to build to some degree over the West Pacific, and that will set us up decently for this fall for a good fall season, or at least a moderate fall season and into the winter. Same thing for snow and precip. If you think differently, I'd like to hear your opinion. Keep me on my toes, keep me guessing. All right, that's our video for this week. If you enjoyed it, please give us a thumbs up. If you haven't subscribed, and I know the subscriber volume, a little bit at a time, is ticking up. I appreciate every one of you for taking the time to subscribe. You get a notification when the videos are posted. To get that, just click the Stormsurf icon down here on the lower right-hand corner of your screen. That'll get you signed up. Comments, questions, always welcome. And of course, many thanks to everyone that has been so kind and gracious and donated to help keep this channel going. I do really appreciate all your contributions. It means a lot to me, so thank you very much. All right, that's it for this week. We will do it again next week. Same time, same channel. Stay safe, go have some fun, get some surf, and we'll see you next week.